Fixed gauges. An outstanding American contribution to the vast industrial growth of the present century is the development of mass production, which depends upon the interchangeability of parts, and this in turn depends upon accurate measurement and fixed standards of precision. Many special types of measuring tools have been devised for easy and rapid measurement to precise standards of the numerous parts, large and small, made by mass production methods. For example, this inspector is gauging mass-produced parts that will go into airplane engines using special gauges made specifically to the limits allowed for each part. Most of the measuring tools used in mass production are fixed gauges. Fixed gauges differ from other measuring instruments, such as the micrometer caliper, in that a fixed gauge is not adjustable while in use. Some fixed gauges, such as this snap gauge, can be adjusted within a narrow range of settings, but the settings made remain fixed. Every drawing contains the required information about dimensions, and where parts are to fit closely, you will find the allowable tolerances stated. For example, the diameter of this shaft is given as 1.250 plus 0 and minus 0.0005. This means that the shaft cannot be smaller than 1.2495. This shaft can be measured with a snap gauge, which is a fixed gauge set to the tolerance specified in the drawing. There are many types of fixed precision gauges. They include snap gauges for outside dimensions, ring gauges, also used for gauging outside dimensions, plug gauges used for internal dimensions, taper plug gauges for internal tapers, taper ring gauges for external tapers. In some plants, there may be hundreds of sizes and kinds of fixed gauges, each designed for some particular part or group of parts. Snap gauges are fixed gauges designed for taking outside measurements. They are made in a wide variety of sizes and designs. One of the most commonly used types is represented here. It has a large flat gauging surface called the anvil fixed on one jaw and two gauging buttons in the other jaw. One, which is called the go button, is set at the maximum dimension allowed by the tolerance which is specified for the work, and the other, which is called the not go button, is set for the minimum dimension allowed. The difference between the two is the tolerance allowed by the gauge. Fixed gauges should be used with care to reduce wear and to maintain accuracy. The correct way to gauge a round piece is to place the anvil gently on the work and with a smooth rolling motion, push the go button past the work. If the go button passes the work and the not go button is stopped, the work passes inspection. If the go button does not pass freely, the gauge should not be forced. Remember that the go button is set out as far as the tolerance will allow. Forcing it past an oversized part may damage the gauge and render it useless for precision measurements. Handling the gauge in the correct manner will assure its precision over a long period of time. To gauge a small part, it is rolled gently into the gauge and under the go button. If it is stopped by the not go button, its dimension is within the tolerance allowed. The gauge is marked to indicate the size to which it is set. This one shows that work smaller than 0.502 and larger than 0.498 will pass inspection. Snap gauges are also used to gauge distances between parallel surfaces. In gauging parallel sides, the gauge should approach the work so that the gauging members are square with the surfaces to be gauged. Only a light hand pressure should be used. If the work is between the limits set up in the gauge, the not go button will not pass the work. However, if the work is undersized, the not go button will slide by. This usually indicates that the work must be scrapped. Adjustable limit gauges, such as snap gauges, can be set to a precise dimension only through the use of master gauges or precision gauge blocks. Such adjustments are made in the gauge control department of the manufacturing plant and should never be attempted without suitable facilities and experienced skill. Go, not go ring gauges are used for checking outside dimensions of round parts. In use, the gauge should approach the work straight and be brought over it without twisting or turning. The not go ring gauge can readily be identified by its annular groove. Taper ring gauges are used for checking both the size and the angle of tapers. If the work cannot be shaken in the gauge, the angle of taper is correct. When the small end of the work lines up with the limit mark, it is of the right size. Screws are gauged with thread ring gauges and other special types. The work should pass freely into the go gauge. Be sure there are no burrs on the work. They will prevent the thread from entering the gauge. The thread should not enter the not go gauge for more than 1 1/2 turns. A convenient tool widely used for gauging screw threads is the roll thread snap gauge. It is capable of much more rapid use than most other types. The work should pass the go rolls freely and, of course, should be stopped by the not go rolls. Gauges used to check dimensions of holes are called plug gauges. Plug gauges are divided into two principal classes, straight plug gauges and taper plug gauges. Single plug gauges are made for a single fixed dimension and are not used where work has to be gauged between tolerance limits. The size is marked on the end. Go, not go plug gauges are capable of gauging a hole within the limits set up in the gauge. Go, not go plug gauges, such as this one, have gauging members at both ends and are called double-ended gauges. The size of each gauging member is clearly marked. The go end enters the hole freely. The not go end, which is the shorter of the two, should not enter. Another type has the go, not go gauging members arranged in steps. This type is called a progressive plug gauge. On a blueprint, we see the dimensions of a hole as 0.624 plus 0.001 and minus 0. To gauge this hole in the finished work requires a go, not go plug gauge, which will have one gauging member with a diameter of 0.624 and one gauging member of 0.625, a difference between them of 0.001, the tolerance allowed. If the hole has been properly made, the go gauging member, 0.624, slips readily into the hole, but the not go member, 0.625, will not enter, indicating that the hole passes inspection within the tolerance allowed on the drawing. The accuracy of any fixed gauge is classified according to the type of work for which it is designed. Some gauges are made to within a few 100,000ths of an inch of the rated gauge size. To maintain such a degree of accuracy in the gauge demands the greatest of care in its use. The edges of a hole should be smooth. Any burrs, if they are present, cause undue wear. The hole should be clean and free of foreign particles. If not, the lapped surfaces of the gauge may become scratched and worn. A plug gauge should go straight into the hole and should not in ordinary use be rotated as it goes in and out. If the straight in and out procedure is followed, less wear will result and the accuracy of the gauge will be maintained longer. Even with the greatest of care, gauges wear and must be checked periodically on precision instruments. If worn beyond the limits allowed in the shop, they must be replaced. Taper plug gauges are made in many sizes and with various angles of taper. They are used to gauge both the sizes and the angles of tapered holes. This is a number 2 Morse taper plug gauge. The limit mark is in the form of a fine groove encircling the gauge. This gauge checks both the angle of the taper and the size of the hole. If the taper is correct, the gauge cannot be shifted sideways, and if the hole is of the right diameter, the limit mark will line up with the end of the work. Another type of taper plug gauge has a tang at the small end. It is used to check the tang recess, if such exists in the part, as well as the taper and hole diameter. If the tang readily enters the recess and the taper fits the hole snugly, the part passes inspection. Taper plug gauges are made in a great variety of sizes and angles of taper. The limit mark on this one is in the form of a flat. A widely used type for checking internal dimensions is the flat plug gauge. Go and not go gauging members are on opposite ends. This type is particularly useful in gauging large holes. Its light weight contributes to ease in handling. Another kind of gauge, usually of special design for each specific job, is the flush pin gauge, widely used for checking depth dimensions. The pins are brought into contact with the location to be gauged. The tops of the pins are cut in steps to the limits allowed. The lower step should be flush with or be below the top surface of the gauge. The higher step should be flush with or be above it. Screw plug gauges used for checking internal screw threads are made in a large variety of sizes and shapes. Screw plug gauges usually have a chip groove cut for the full length of the thread on the go end of the gauge for the purpose of clearing chips out of the thread to be gauged. The gauge should enter the hole freely and should be run down to the bottom. The not go end should not enter the hole more than 1 1/2 turns. Mass production depends upon fixed gauges for quick and accurate gauging of interchangeable parts. Constant inspection of products must be maintained to assure the precision required for interchangeability, and for this reason, fixed gauges are the special tools of the inspector. The gauges employed for inspection must be used with the same care as those used for gauging work while it is being produced. But careful use is not enough. All gauges must be checked periodically with master gauges or gauge blocks to determine their precision. For this reason, one of the most important sections of a modern plant is the Gauge Control or Gauge Inspection Department, where all gauges and other measuring tools are checked and adjusted. Here we see precision gauge blocks being used with an electrolimit gauge to check the accuracy of a flat plug gauge. Precision measurement and its control depend upon the operator's skill and care in the use of his gauges. All these elements together make possible the successful interchangeability of parts required in mass production.